Welcome to our channel Sankalp Study Success. Today in this lecture, we are going to see about the very first topic, which is deterministic finite automata. So here, generally finite automata is of two types, which is deterministic finite automata as well as non-deterministic finite automata. So now first let us discuss what is deterministic finite automata. Then we will go into non-deterministic finite automata. Now, how do you define deterministic finite automata? Generally, it is defined as a 5-tuple notation where m is equals to q sigma transition function q naught and f, where we have already discussed in the previous lecture. If you watch it, q is nothing but set of states, sigma is the input's alphabet. Transition function, it is defined as transition function maps from q cross sigma tends to q. So this is our transition function, and q naught is the initial state where f is the final state. So now let us see what is deterministic finite automata. Here on each and every state, if we apply each and every input symbol, then there should be a one transition. That means there should be a unique transition. That means what? There are two states, for example, q0 and q1. So, and you are having sigma is equals to 0, 1, which is nothing but the input symbols 0 and 1. So, if you have to apply for each and every state, you have to apply 0 and 1. Ante, మనకి ఎన్ని స్టేట్స్ ఉన్నాయో అన్ని స్టేట్స్కి అన్ని ఇన్పుట్ సింబల్స్ అప్లై చేస్తే మనకు ఒక యూనిక్ ట్రాన్సిషన్ రావాలి. అంటే ఓన్లీ వన్ ట్రాన్సిషన్ రావాలి, సెవరల్ ట్రాన్సిషన్ రావద్దు. సో దట్ మీన్స్ యూ హ్యావ్ టు అప్లై 0 from q0 and also you have to apply q1. It may be if you can move from one state to another state, or it may be from that state to that state itself. You have to just apply 0 and 1 in order to get a unique transition. That is called as deterministic finite automata. Here, let us see one more, the same thing, which is defined as the term deterministic refers to the fact the term each input there is one and only one state to which the automaton can transition. That means what? One and only one transition should take place for any input string. So, finite state machines that accepts or rejects strings of characters by parsing them through a sequence that is uniquely determined by each string. So here the given three definitions are one and the same, but they are defined differently. So deterministic finite automata is nothing but on each and every input symbol you are going, on each and every state you are going to apply each and every input symbol in order to get a unique transition. So let us solve some problems related to deterministic finite automata so that you will be clear with the DFA. So now design a finite automata for the language. What is the language given here? Set of strings starting with A. That means the language should consist of only the strings which are starting with A over an input alphabet A, B. Using A and B, you have to generate some strings such a way that A is the starting symbol. That means let us write L is equals to, single A is also a string, right? Single A, you can also take it as AB, AA, triple A, that means any number of A's, or A followed by any number of B's, or it is maybe a combination AB, AB, AA, and so on. You can take any number of strings, but only condition is the string should start with A. So if you take BA, this is not a valid string. If you take BABAA, this is not a valid string because it is starting with B. So you have to take only the strings which are starting with A. Now, what is the input alphabet given for us? A, B, which is given in the question itself. So now, Generally we'll take Q0 as the initial state, right? So Q0 is the initial state. Now let us draw the transition diagram for the finite automata, because we have to design the finite automata, which is nothing but the transition diagram. So now let us start with Q0, which is the initial state. Generally we will start with the Q0, because for every problem every string should start its processing from the initial state. So Q0. So we have to design it step by step. So now let us consider A. From Q0 to Q1, there is a transition by applying an input symbol A. This is a valid string. That means it should reach to the final state. So let us make Q1 as the final state. Okay, so Q0 and Q1, by applying A to Q0, it is moving to Q1, which is nothing but a final state. That means this is valid. Now AB. Generally, if you think, we are starting with A and it can be followed by any number of A's and any number of B's, correct? So any number of A's and B's means it is nothing but a self loop, right? Self loop on Q1, which is nothing A comma B. That means after A we can have any number of combinations of A and B. మనకి ఫస్ట్ ఏతో స్టార్ట్ అవ్వాలి, బట్ ఎండింగ్ అనేది ఏతో ఎండ్ అవ్వచ్చు, బీతో ఎండ్ అవ్వచ్చు, కాంబినేషన్స్ కూడా ఉండొచ్చు. సో వీఆర్ ఎండింగ్ విత్ అ సెల్ఫ్ లూప్ విచ్ ఈస్ A comma B. But here you need to apply for each and every state you have to apply each and every input symbol. Here for Q1 we have applied A and B, so it is done. For Q0 we have applied A, but we didn't apply B yet. So we need to apply B also in order to make it DFA. So if a string is starting from B, then it should not go to the final state, right? So from Q0 you can't apply B and you can't make it final state. So what happens if you keep self loop to Q0? If the self loop is given to Q0, then BAB will be accepted. Also BA will be accepted, because self loop, if you keep self loop B, then BA, this is reaching to the final state, so it is accepting it. So that means what? It should not be accepted. So let us take one more state as Q2, which is not the final state, and if you apply B to Q0, it reaches to Q2, which is not the initial state. And for again coming to the definition, for each and every input symbol, for each and every state you are going to apply each and every input symbol. That means for Q2 also, if you apply self loop of A comma B, then it becomes a DFA. So you can check whether any valid string is accepted. Your DFA should be in such a way that valid string should be accepted and invalid string should not be accepted. So this is the transition diagram. In this way we are going to draw. Now let us see the transition table, how to draw the transition table. Here rows represents, what do we represent in rows? There are it is a transition function. Rows denotes Q0, Q1 and Q2, right? Where Q0 is the initial state and Q1 is the final state. And also columns denote A comma B, which is nothing but the input symbols. So let us draw the transition table. If you apply A to Q0, then it is moving to Q1. If you apply B to Q0, then it is moving to Q2. In the same way, if we are applying A to Q1, then it is moving to Q1 itself. And if we are applying B to Q1, and it is again moving to the Q1. Now again for Q2, if you apply A, it moves to Q2. Q2, if you apply B, then it moves to Q2. This is nothing but the transition table. So in this way, for every question you have to draw the your first step is to write the given data, then you have to draw the transition diagram, then followed by the transition table. Also we have to check for a valid string it is accepted, and for invalid string whether it is rejecting or not. So now let us consider a valid string, which is, now here let us consider a valid string transition function of, you are starting from Q0. What is the valid string? Let us consider ABAB. ABAB is a valid string, right? Because it is starting from A. So for Q0, if you apply A, then it moves to Q1. So transition of Q1, comma, the remaining string is BAB. Now for Q1, if you apply B, then it moves to Q1 because we are having a self loop. So Q1, comma, A, comma, B. Again, if you apply Q1, if you apply A to Q1, then you will get it as Q1 itself because we are having a self loop with A and B. Now, transition function of Q1 comma B, it is nothing but Q1, right? Where Q1 is the final state in our transition diagram. That means we have reached to the final state. So therefore, ABAB is valid. So the string starting with A, we are accepting the string starting with A. We have to also check whether it is rejecting the strings starting with B or not. So let us take one invalid string. What might be the invalid string? BAB is an invalid string, right? Because it is starting with B. So transition function of Q0 comma BAB, where if you apply B to Q0, then it moves to, if you apply B to Q0, then it moves to Q2. So transition function of Q2 comma AB, right? Q2 comma AB. So if you apply A to Q2, then it is moving to Q2. Transition function of Q2 comma, the remaining symbol is B. So if you apply B to Q2, then again you will get it as Q2. So we are getting Q2, where here Q1 is the final state, but if you process the entire string, we are reaching to Q2, which is not a final state. That means therefore BAB is invalid. So in this way, we are going to draw deterministic finite automata, and also some may draw by using only 2 states, some may draw by using 3 or 4 states. So it depends on the individual how do they draw, but the main thing is valid strings should be accepted and the invalid strings must not be accepted from the deterministic finite automata. So we are going to have 5 steps to solve the problem. The first one is to write the given data. Then you have to write the transition diagram, then followed by the transition table, and also you have to check whether any string, valid string is accepted and also the invalid string is rejected. In this way you are going to solve the problems. Now let us see one more problem related to DFA. Design a finite automata for set of strings of length equals to 2. That means here length is specified. Input string length should be only 2. It should not exceed 2 or it should not be less than 2. Over the input alphabet A comma B. Then what will be the language which is generated from this DFA, which is nothing but AA, because length of the string is only 2. There are only 2 input symbols A and B. So AB, then we will get BA, and also we will get it as BB. So only these strings should be accepted and the remaining strings, all the remaining strings should be rejected by the finite automata which we draw. Then the given is sigma is equals to A comma B, and we will generally start with an initial state Q0. Initial state Q0 is always Q0. So now let us draw the transition diagram. First we will start with the initial state Q0. Then here only A and A. Now let us go step by step. First let us consider AA as the input string. So it is moving from Q0 to Q1 by applying an input symbol A. Then also we are going from Q1 to Q2, which we will make it as final state in order to reach the final state by applying AA. So if you are starting from Q0, apply A, then it moves to Q1, and if you apply A, it is moving to Q2. That means this AA is accepted. Now AB, here A is accepted. Then what about B? Here if you write B, that means Q1 by applying A, it is moving to Q2, and also if you apply B, it is again moving to Q2. So A, and here if you are going to consider any one, for the one transition you have to consider only one input symbol. So here A and B is also accepted. What about BA? Here A ending, it is ending with A, but what about starting? Starting, it should start with A, then only it is going to accept BA. That means AB comma AB. Okay, it is accepted, right? If you consider BB, here it is starting with B and also followed by B, and it is reaching to the final state. That means all the four strings which are valid are accepted in this case. And also, in order to make it a deterministic finite automata, for each and every state you have to apply both the input symbols A and B. Here for Q0 you have applied AB, for Q1 also you have applied AB, but for Q2 we didn't apply any input symbol. So in case if you keep a self loop for Q2, then the length of the string will become to infinity. That means up to infinity it will accept each and every string. So we should not take self loop on Q2. That means after AA or after AB, BA or BB, if there are any input symbols, then they should not reach the final state, right? That means let us take one more state, which is Q3, which is not a final state. So if you apply A comma B, then these strings are not accepted and it is not reaching to the final state. And also for Q3 you have to apply two input symbols in order to make it a DFA. So in this way we are going to draw the deterministic finite automata. Then what about the transition table? Here transition function, rows represents the states which are Q0, Q1, Q2 and Q3, where Q2 is the final state. Here we are having two input symbols A and B. So if you apply A to Q0, then it is moving to Q1, and if you apply B to Q0, then it is again moving to Q1. So by using this transition diagram, we are writing this transition table, right? If we are applying A to Q1, then it is moving to Q2, and also if you apply B to Q1, it is moving to Q2. Then by applying A to Q2 or B to Q2, again it is moving to Q3. So here if you apply A and B to Q3, then it is moving to Q3 only, because we are having a self loop on Q3. So this is the transition table which we draw. Here now you have to consider a valid string and also an invalid string in order to know whether the valid string is accepted by the transition diagram and also an invalid string is rejected by our transition diagram or not. So like this we are going to solve the problems. So now let us see a different model problem where the strings are ending with 1. Just now we have seen starting with A. We are done with starting with A, and now we have also seen a restriction on length of the string, which is equal to 2 in the second problem. Now we are going to see the strings which are ending with 1. That means what might be the language generated in this case, which is 1. We can consider 1 because our input symbols are 0 and 1. So 1 is a string which should be accepted because it is ending with 1. 0, 1 is also ending with 1. Double 1 is ending with 1. Triple 1, any number of ones will end with 1. And also combination of 0, 1, 0, 1 is ending 1, 0, 1, 1, 0, 1. And you can take the of any length which is 1, 0, 1, double 0, double, triple 1, 0, 0, 1 and so on. Like this, you can consider any number of strings, but each and every string which you have considered must end with 1. So in this case, all these strings end with 1. Then what is the input alphabet given in the question, which is nothing but 0, 1. So here let us draw the transition diagram where Q0 is equals to Q0, right? Because initial state is nothing but Q0. So let us start with the initial state. Let us go step by step by considering 1 first. So if you consider 1, if you apply 1 to Q0, it is moving to Q1, which we will make it as a final state, because here 1 is a valid string and from the initial state we have started and it should reach the final state. So Q1 is the final state. So now let us see 0 and 1. Generally, any string which is ending with 1, that means the starting of the string can be any number of combinations of 0 and 1. So let us take the self loop on Q0 where any number of combinations of 0 and 1. Now, and also it should end with 1, and also we have, this is the DFA, right? This is the finite automata. Let us make it DFA by applying each and every input symbol. That means here any number of zeros can be there, right? But here there is no need of applying 1 because we have already applied 1 to Q0. So here this is Q0 is moving to Q1 by applying 1. Now if you apply 0 and 1 to Q1, that means if any string ending with 0 must not reach to the final state, right? That means you can go back to the Q0, right? That means if 0, 1, 0, if this is a string, this is not ending with 1, so it should be rejected. That means it should not reach to the final state. So 0, 1 and 0, it is moving to Q0, which is not a final state, so which we have drawn is correct. But if we are going to take now we have to apply 1 to Q1 because in order to make it a DFA. So if you apply 1, that if you take self loop, that means any number of ones can be accepted. So which is nothing but it is again reaching to the final state. So in this way we are going to draw the transition diagram. Now let us draw the transition table for the given transition diagram. Here in the transition table we are going to have only two states where Q0 is the initial state and Q1 is the final state. So our input symbols are 0, 1. Here Q0, if you apply 0, then you will get Q0. Because Q0 we are applying 0, it is reaching again to the Q0. And here if you apply 1 to Q0, then it is moving to Q1. Then if we are applying 0 to Q1, then it is moving to Q0. And here if you see Q1, if we are applying 1 to Q1, it is again reaching to Q1 only. So this is the transition table, and in this way we are going to draw DFA. So now let us see another model question, which is a set of strings consisting of a substring ABA. That means what? In the string, a substring ABA should be involved. That means it should consider any string. If you consider that string must consist of ABA. That means what? Let us see which is the language generated from this set of strings consisting of ABA. That means we can take ABA, we can take AA, BA, BB, because ABA is there in the string, and also you can take ABB, ABA, BB, AA. Length of the string can be anything, but the string must consist of ABA substring. So in this way you are going to generate the language. So here our input alphabet is nothing but A, B, which is given in the question, and we are going to start with the initial state Q0. So here let us draw the transition diagram wherein you are going to start with Q0 as the initial state, and here you have to have ABA. That means ABA should be accepted. It is a valid string. Generally, it is easy if you consider these many states. That is, if you apply A to Q0, it is reaching to Q1. Then we have to apply B, wherein it will reach to Q2. And then if you are applying A to Q2, then it should reach to Q3 and it should be the final state, right? Because ABA is the substring which should be accepted. That means ABA is accepted in this case. Now we have to make it a deterministic finite automata by applying each and every input symbol. That means to Q0, we have to apply B because A is already done. So if you apply B, how can you apply B here? If you take self loop of B, then any number of B's can be accepted before ABA. That means what here? Triple B ABA is again valid string here. Any number of B's if you take, we are having ABA, so we are going to reach the final state. So we can take self loop here. Now coming to Q1, can you take self loop here by applying A? Yes, right? Because any number of A's if you consider, then you will have A, B, A, then the string will be valid. So here in this case, you can also apply A as the self loop. Now here for Q2, we have applied A already. So can you apply self loop of B here? No, because here if you apply self loop of B, any number of B's will be having, and then you will have B and A, but a substring ABA will not be there. So we are not going to take self loop on Q2 with applying B. So what happens? Here from Q2, if you move to Q0 by applying B, then will it be valid? Here if there is a B, then it goes back again, there is ABA. That means the string is accepted, right? So in this way you have to think and you have to just move from one state to another state. And also for Q3, here we are done with the substring ABA. Before substring ABA, you can have any number of A's and B's, and after the substring of ABA, you can have any number of A's and B's. So you can consider a self loop with A comma B. So this is the transition diagram. Transition table becomes transition function and also the states Q0, Q1 and Q2, where Q0 is the initial state and Q3 is the final state. So we are having two input symbols A comma B, which are nothing but we will denote it in columns. Here if you apply A to Q0, then we are moving to Q1. Here if you apply B to Q0, then we are again moving to Q0. So in this way we are going to write all the states which are moving from one state to another state by applying the input symbols. So if we apply A to Q1, then we are moving to Q1. If you are applying B, then it is moving to Q2. So for Q2, if you apply A, it is moving to Q3, and if you apply B, it moves to Q0. For Q3, if you apply A and B, it is moving to Q3. So this is the transition table for the substring ABA. Then we have to consider a valid string which consists of ABA, and also we have to consider an invalid string wherein we are not having ABA. That means, for example, what is an invalid string? Which is triple B double A. It is an invalid string because there is no ABA in the given string. So we have to check whether the valid string is accepted by DFA or not, and also we have to check whether an invalid string is rejected by DFA or not. Now coming to the next question. Design a finite automata for set of all strings starting with AB. So here this string should start with AB. So what might be the language generated here? AB is from AB you have to just start. That means after AB you can have any number of combinations of A and B. So here we are having AB, so our input alphabet will become A comma B. Okay, so our input alphabet will become A comma B. Just change it with, replace 0 and 1 with A and B. So if you start the string with AB, generally ending of the string can be anything. So let us take AB. You can also take ABA. The length of the string can be anything, AB, triple A, double B, and so on. That means the string should start with AB and ending can be anything. In that case, the strings are accepted. So here, input alphabet is A comma B and our initial state is Q0. So let us draw the transition diagram where you are going to start with Q0, and if you apply A, then it is going to Q1, because we have to draw it step by step by considering each and every string so that we can know whether it is accepted or rejected. So for Q0, if you apply A, it is moving to Q1, and then if you apply B, then it will move to the final state Q2, because AB is the valid string, so it should be accepted and it should reach to the final state Q2. So here AB is accepted. What about the end of the string? End of the string can be any combinations of A and B, because there is only restriction at the start of the string, that is AB. End can be any number of combinations of A and B. So it is true. But what if it is starting with B? That means what the string if it is starting with B? It should not reach to the final state. That means let us take one more state Q3, and there is a transition from Q0 by applying B, then it is moving to Q3. And also here, if we are having, if here, this is the DFA, right? But if we are going to apply both the input symbols to each and every state, that means here for Q0 we have applied two input symbols. We are done with Q0. For Q1 you have applied just B but not A. If here we are going to have A, if it is moving to Q2, then AA will also be accepted. But this is not the valid string, because it should start with AB. So if you get A, then it should not move to the final state. So that means it can move to the Q3, which is not a final state. So here we have applied A and B. We are done with Q2. And also, if you apply A comma B to Q3 as a self loop, then the deterministic finite automata is done, because for each and every state you have to apply each and every input symbol. So here, now let us draw the transition table for given transition diagram. How do we draw the transition table? We already know, wherein you are going to take all the states Q0, Q1, Q2 and Q3, where Q2 is the final state and initial state is Q0, and A comma B is the input symbols which we apply. So here this is A and B, right? So let us take A and B, A, and here we are having B. So for Q0, if you apply A, it is moving to Q1, and for Q0, if you apply B, it is moving to Q3. Then for Q1, if you apply A, then it is moving to Q3, and if you apply B, it moves to Q2. Then for Q2, for both the cases, it is moving to Q2. Then for Q3, if you apply A and B, it is again moving to Q3 only, because there is a self loop. So in this way, we are going to draw the DFA for the strings starting with A and B. Now let us solve another question of different model, which is DFA that accepts all the numbers which are divisible by 2. That means here we are given with the input alphabet 0 and 1. Input alphabet is 0 and 1, but he is asking that the numbers divisible by 2. That means we know that what are the numbers divisible by 2, which are nothing but 2, 4, 6, 8, and 0 is also a number which is divisible by 2, right? So all the numbers ending with these digits are divisible by 2. That means you have to take all the digits which are divisible by 2 in the binary format, because our input alphabet is 0 and 1. So we can represent using 0 and 1, we can represent only in the binary format. So now let us convert these numbers into binary format, where 0 is 0 0, 2 is nothing but 1 0, 4 is nothing but 1 0 0, 6 is 1 1 0, 1 0 0, and so on. Like this, there you have to convert all the numbers into binary format. Then what are the numbers which are not divisible by 2? Not divisible, because these numbers should be rejected, right? 1 3 5 7 9 and so on. Here also we are having many. So 1 is nothing but 0 1, 3 is nothing but 1 1, 5 is 1 0 1, 111 is 7. So in this way you have to convert all these numbers into binary format. Here if you observe, if it is divisible by 2, then it is ending with 0, and if it is not divisible by 2, then it is ending with 1. That means what? Our finite automata is accepting only the numbers divisible by 2. That means it should end with 0, and it should not end with 1 because it is not divisible. So now let us draw transition diagram, where we are going to start with the initial state, which is Q0, and if you 0 0 should be accepted. That means Q1, which is a final state, and 0 is accepted. Any number of zeros should also be accepted, right? Because any number of zeros is also equal to 0 itself. So 0 should be accepted, which is moving to the final state, so it is accepted. Just now we have discussed the any string ending with 0 is divisible by 2. That means we can have a self loop with 0, right? Yes. Now, if we are having self loop with 1 here, so there is no problem because it is ending with 0. If it is ending with 0, then it is divisible, so it is accepted. Now, you have to apply 1 to Q1. So, if you apply 1 to Q1 by moving to Q0, then it is not ending with 1, because if you take the self loop of 0, 1, that means then 1, 3, 5, 7 and 9, which are odd numbers, those are also will be accepted. So we are moving from Q1 to Q0. Now this is the transition diagram for the numbers which are divisible by 2. Then here we are going to take the transition table. For this transition diagram, we are going to draw the transition table, where Q0 is the initial state and Q1 is the final state, by applying 0 and 1 as the input symbols. Now, if you apply 0 to Q0, it moves to Q1. If you apply 1 to Q0, then it is moving to Q0. Here, if you are applying 0 to Q1, it is moving to Q1, and if you are applying 1 to Q1, it is moving to Q0. So this is the transition table which you get for the numbers divisible by 2. అంటే ఏదైనా నంబర్ 2తో డివిజిబుల్ అవ్వాలి అంటే అది 0తో ఎండ్ అవ్వాలి. 0తో ఎండ్ అవ్వాలి అంటే ఎనీ నంబర్ ఎప్పుడైనా లాస్ట్కి సెల్ఫ్ లూప్ ఉంటే ఫైనల్ స్టేట్కి అది ఖచ్చితంగా 0తోనే ఎండ్ అవుతుంది. సో 1తో ఎండ్ అవ్వకూడదు కాబట్టి వీఆర్ మూవింగ్ ఫ్రమ్ Q1 to Q0. సో in this way we are going to draw the transition diagram for the numbers divisible by 2. This is the DFA for the numbers divisible by 2, accepting two divisible numbers. So this is one of the important question wherein you may expect for the external exam, which is divisible by 2, or you may also get divisible by 3. So now let us see the numbers divisible by 3. How do you find out the numbers divisible by 3? Here, what are the numbers divisible by 3? 0 is divisible by 3, 3 is divisible, 6, 9, 12, 15 and so on. These are the numbers divisible by 3. And what are the numbers not divisible by 3? 1, 2, 4, 5, 7, 8 and so on. These are the numbers which are not divisible by 3. So Why are we considering both divisible and not divisible? Because the divisible numbers should be accepted and the not divisible numbers should not be accepted. So like this we are going to take, and now the input alphabet is nothing but 0 and 1. That means we need to convert all these numbers into binary format. So 0 is nothing but 0 0, 3 is nothing but 1 1, 6 is 1 1 0, 1 0 0 1, 1 1 0 0, which is 12. Like this you are going to take all the numbers in the binary format, and here 0 1 is 1, 1 0 is 2, 1 0 0, 1 0 1, 1 1, and so on. These are the numbers in the binary format which are not divisible by 3. So now we are going to draw the DFA, where we are going to take from the initial state. And here one of the most important thing which you have to remember is, if the questions related to divisibility of 2, 3, 5 and so on, if the questions are related to divisibility, then you will be knowing how many number of reminders you will get if the number is divisible by 2, right? Number of reminders. So if it is divisible by 2, then you will get 0 and 1. Only 2 reminders you will get. If it is divisible by 3, then you will get 3 reminders, 0, 1, 2. In the same way, if you take number divisible by 5, then you will get 0, 1, 2, 3, 4. That means you will get 5 reminders. So number of reminders will be the minimum number of states. That means how many number of reminders you are getting, that many minimum number of states should be considered in order to draw DFA. You can take more than the minimum number of states also, but if the number is divisible by 3, minimum number of states should be 3 for sure. If the number is divisible by 2, then the minimum number of states should be 2 in order to draw DFA. So that means if you are taking the numbers divisible by 3, for sure number of states should be equal to 3. Minimum number of states, this is minimum. So let us take Q0, Q1 and Q2. Q0, Q1 and Q2. Now any number of zeros are accepted, right? That means if you make this Q0 as the final state and if you take a self loop with 0, then it is accepted, right? And then 1 1 is also accepted. Here we are done with 0 0 and 1 1 should be accepted. That means from Q0 if you move to Q1 with 1, and from Q1 again if you move to Q0, then 1 and 1 is accepted and it is reaching to the final state. So we are done with 1 1. And then again 1 1 0 is also accepted, right? 1 1 and 0, it is accepted already. Now 1 0 0 1 should be accepted. How 1 0 0 1 is accepted? Here we are done with 1, and from Q1 if you move to Q2 by applying 0, and then again if you come to Q1 by applying 0 and 1 0 0 1, that means it is reaching to the final state. So in this way we are going to draw, but we have applied 2 input symbols to Q0, 2 input symbols to Q1 and only 1 input symbol to Q2, and here we have to apply 1 also. How do you apply 1? That means 1 1 0 0 should be accepted. See here, 1 1 0 0 is accepted. Every number is accepting. Here 0 1 0 1, it is not accepted because it is not going to the final state. So like this you have to draw. Here if you take a self loop of 1, that means 1 0 1 should be rejected, right? 1 0 1 is rejected. If it is any number of ones, then it should be rejected because it is not divisible by 3. So in this way we are going to draw DFA for the numbers divisible by 3. Then here you have to again draw the transition table, as well as you have to take a valid string and check whether it is accepted or not by DFA, and also take an invalid string and check whether it is accepted or rejected by DFA. If it is rejected, then our DFA is correct. So in this way, we are going to draw DFA for the numbers divisible by 3. So these two questions are the most important and the expected questions in the external exams. So now let us see a different model question wherein the numbers divisible by 3. We have just done it for binary system. But here the question is divisible by 3 for base 3 system over the input alphabet 0, 1. That means for base 3 system, how we are going to draw? We know that. Let us convert the numbers into base 3 system first, which is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So let us take single digit numbers and let us convert into base 3 system. That means 0, 0. Base 3, which is nothing but 0. 0 is always 0, right? Here 0, 1. That means first you have to convert into binary format. 100 base 3, 101 to the base 3, 110 to the base 3, 111 to the base 3, and what is 8, which is 1000 to the base 3, 1001 is to the base 3. Like this you need to convert into binary first, and then now let us convert into base 3 format. That means 3 to the power of 0 into 3 to the power of 1, right? That means any number. Now if you take 8, this is 3 power 0, this is 3 power 1, this is 3 square and this is 3 cube. Now these are completely zeros. 3 cube is nothing but 27. That means 8 value is 27. So like this you have to convert into base 3 system. This is nothing but 1, right? Now then here we are going to get 3. Then here 3 plus 1 is 4. Then 3 power 0, 3 power 1 and 3 square, which is nothing but 9. 9 plus 1 is 10. So 9, 10. Then in this way you are going to convert 12, 13, 27 and 28. Like this you are going to convert into base 3 system. Now you have to check whether this base 3 system is divisible by 3 or not. That means if you do mod 3, then you should get the remainder as 0. In this case it is 0. Mod 3, which is 1. Mod 3, again it is 0. If you do mod 3, it is 1. 3, it is 0. That means what? If you are doing mod 3, this is 10, right? That means it is not 0, it is 1. So mod 3, it is 0 again. Mod 3, it is 1. So that means what? If you are dividing the numbers with 3, you are getting the reminders as only 0 and 1. That means you are getting only 2 reminders. That means minimum number of state are 2. So any number which is divisible by 3 in the base 3 system, we are getting 0 and 1 as the reminders. That means what? Now we are going to draw DFA by using only 2 states. Minimum number of states are 2, Q0 and Q1. Now if the reminders are 0, then these should be accepted by DFA and the remainder 1 should not be accepted by DFA. So if you see, this is accepted, this is accepted, this is accepted. That means what? All the numbers which are ending with 0 in the binary format are accepted, right? That means this is the initial state, and if it is 0, then it is accepted. So it should end with 0, then only it is accepted. End with 0 means you can have self loop because any number of zeros are at the ending. That means it is accepted. So if you are getting 1 at the end, then it should come back again, right? And it can start with ones, any number of ones, but it should only end with 0. Then only it is accepted. So if you observe carefully, this transition diagram can also be taken for the divisibility rule of 2, right? For divisibility rule of 2 in the binary format, we are going to get the same DFA. So like this, we have to draw the DFA by taking minimum number of states, and also you can consider greater than the minimum number of states. You may consider 3 states, 4 states. That is up to you, but you have to draw DFA in such a way that valid strings should be accepted and invalid strings should not be accepted. So this is one of the model of divisible by 3 in the base 3 system. Now coming to the most important question, and it is the most repeated question in most of the exams, where DFA, which is accepting even number of zeros and accepting even number of ones. That means what might be the language which is generated here. So let us take L is equals to 00, even number of zeros, right? Here even number of ones, which is accepted. 1100, 0011, 4 zeros followed by 11. So 4 zeros, 11, 00, triple, 4 ones, 00, and so on. In this way, any length can be anything, but it should accept even number of zeros and even number of ones. If it is accepting in such a way, then the DFA will be the true. Now let us take, we know that input alphabet is 0, 1, and we are going to start with the initial state Q0. Now let us draw the transition diagram for DFA. That means we are going to construct a DFA. So we are starting with the initial state Q0, and here 0, 0 should be accepted. You are going to Q1 by applying 0. Now what happens from Q1? If you apply 0 to Q0 and if you make this Q0 as the final state, then this 0, 0 is accepted. That means if you take any number of even number of zeros, then it is accepted. 2 zeros, 4 zeros, that means 2 times, 6 zeros, that means 3 times, so it is accepted. But now this 1, 1 also should be accepted. That means by applying 1, if you are coming to Q2, and even number of ones should be accepted, then again if you move to Q0, then it is accepted. But if there are odd number of zeros and odd number of ones, it should not be accepted, right? That means if you take Q3 from Q1, if you move to